Good morning, everyone, and welcome to our lecture, Algebra and Variables. My name is Stephanie. Let's get started. So in today's lecture, we're going to talk about variables. So we're going to start off with some important definitions. A variable is a letter used to hold the place of one or more numbers. So to say this more simply, a variable is a letter and it represents a number. Usually it's an unknown number. Usually we know the number if it's given to us, but it is a letter that represents one or more numbers. So let's go ahead and fill this in for some examples. An example of a variable, the most famous, of course, is going to be x, y, z, and if you take statistics, you'll probably see t, s, and n. All of these are variables. They all represent one or more numbers. Our second definition is going to be variable expressions. And variable expressions are made up of numbers, variables, and operations. So an example of a variable expression would be something like 2x, maybe something like c divided by 14, maybe something like a to the 8th, or 9 minus y, or 8 plus 6x. So if we look here at 2x, we have a constant, we have a variable, we have an operation. So here's our number, here's our variable, and these two things are being multiplied together, so that is our operation. That is a variable expression. It's very simple. Maybe you can add different examples in here that you can think of. I'm sure they would all be right. So let's go ahead and move on to the next slide. So we're going to do an example. We're going to state the meaning of a variable expression in English in plain language that we can understand, and we're going to name the operation. So there's our table, and we're going to work on this big table. So you see our variable expressions here to the left, and in the middle, we're going to write what it means in words, and to the far right, we're going to fill in what the operation is. And this is just to get you accustomed to describing what is happening so that you understand what to do. So for the first one, we see 11 plus b, and we're going to write just that, 11 plus b. And our operation will be addition. So we write addition, or if you want to, sorry about that, it'll be plus, if you just want to write something quick. Our variable expression, the second one, will be 23 minus m. So we're going to write 23 minus m. And our operation is going to be subtraction. Okay, or you can just write minus. Our third variable expression is t divided by n. So you write t divided by n. And our operation will be division. You can do the division sign, or you can do a fraction bar. Our next variable expression will be 19 times c. So we write 19 times c. And our operation will be multiplication. And we're going to write a dot. We do not use x to denote multiplication anymore because x is a variable now. X represents a number, and if we want to denote multiplication, we use a dot, we use parentheses, or we put two numbers close together with a variable like this. That's multiplication. Our next variable expression is g minus 4, so I'm going to write g minus 4. And the operation here is subtraction. Easy enough, right? This is a good exercise for you to practice so that you can understand what is the variable, what is the operation, and what am I going to do? That's something you're going to have to think about as we learn to substitute, which we will learn pretty soon. So let's go ahead and go on to the next example. So In order for us to be able to evaluate variable expressions, we're going to have to substitute the numbers for each variable. For some problems, we're going to say p is equal to 1, and we're going to have to solve or evaluate our variable expression. So what does it mean to substitute? I would like for you to think about what other times you've heard of that word. Maybe when you were in school and one of your teachers was absent, you had a substitute. Maybe you have an allergy and you have to think about protein substitutes or gluten substitutes. So what does that mean? Go ahead and think about it and then write your response. For me, I'm going to say, to me, substitute means to replace or in place of. So it's taking the place of. So when we substitute, we're taking the number that we're given and we're putting it in the place of the variable, in the place of the letter. So other names for this method for us to substitute and evaluate expressions is going to be the plug and chug method, where you literally plug in the numbers where you see the variables and you chug. You perform the operations that are being asked. And that's why it's important for you to know what is happening. Is it minus? Is it plus? Is it multiplication? Is it division? So let's go ahead and try some examples. So our first example states, evaluate the expression when x is equal to 3. So now we have our table. To the far left, we have our variable expressions. In the middle, we're going to substitute. And to the far right, we're going to simplify. So let's go ahead and get started. Right up here, to begin with, I always like to write what my given value is. So x is equal to 3, so that I know that wherever I see an x here on the left-hand side, I'm going to replace that with a 3. I'm going to substitute a 3 every time I see an x for this problem. So beginning with the first one, it's 6 times x. So it's going to be, I'm going to write 6 times 3. And this will be 18. For the next expression, I have 10 minus x. So I'm going to write 10 minus 3. And once I perform the operation, that'll be 7. For the third example, I have x plus 22. So I'm going to write 3 plus 22. And I add, and that's going to be 25. For the last expression, I have 9 divided by x. So I'm going to put 9 divided by 3. And 9 divided by 3 is 3. Fairly simple, really straightforward. We're using what we did in the last example of describing these expressions in language so that we know what to do and we can get to our answer. So I hope this is all making sense. Go ahead and jot all this down so that we can move on to our next example. Okay, so for our next example, it is evaluate the expression when y is equal to 2. So again, we have our expressions on the left-hand side. In the middle, we're going to substitute, and in the far right, we are going to simplify. So let's go ahead and get started. To begin, I'm going to write y is equal to 2 here so that I know every time I see a y on the left-hand side, I'm going to replace it with a 2. I'm going to substitute a 2 for the y. So for the first one, it says 12 times y. So I'm going to write 12 times 2. And when I multiply, this will give me 24. Moving on to the next one, I have 2 minus y. So I'm going to write 2 minus 2. 2 minus 2 will give me 0. For the third expression, I have y plus 9. So I'm going to write 2 plus 9. And this will give me 11. For the fourth one, it's 4 times y. So I'm going to write 4 times 2. 4 times 2 gives me 8. And finally, 10 divided by y is my last expression. So I'm going to write 10 divided by 2. 10 divided by 2 gives me 5. So that was fairly simple. As you can see, a lot of these definitions, a lot of these things that we're doing, describing the variable expressions, substituting, these build off of each other. So I hope that you've gotten some practice, and let's move on to our next example. We have a math tip. So remember I mentioned that we do not use x to denote multiplication anymore. We're not going to do that. Instead, we're going to use three different ways to express multiplication. So the first one is going to be fairly simple. It'll just be like this, x, y. This means multiplication. I don't know if you remember something like this, 2x. That shows us that this is being multiplied together. The second way that we can express or that we can write multiplication of x times y is we can use grouping symbols or parentheses. Grouping symbols is just a fancy word for parentheses and brackets, but they're really helpful in clarity and really explaining what we're doing. So an example of that could be like 3 times 4, something like that. And finally, our last way to write multiplication is going to be x dot y. Very simple, right? And you would probably see this like 5y dot 5y dot 5y. All of these mean multiplication. So no more x. That is not a part of multiplication anymore. So instead of writing this, 2 times 3 is equal to 6, we can write 2 times 3 is equal to 6, or maybe we can write 2 times 3 is equal to 6, okay? So this is sad face. No, we're not using x for multiplication to express multiplication. These down here, yes, okay. Hopefully you can remember that. Alrighty, so we're going to do a challenge question. We're going to use what we learned about variable expressions, substitution, and simplifying to do this problem, and I know that you can do it. So let's go ahead and read it. We're going to find the distance d traveled in 3 hours by a car going an average speed of 60 miles per hour. And we're going to use the formula distance equals rate r multiplied by t. And I forgot to let you know that t means time. Okay, so our approach down here is that we're going to write the formula for distance. We're going to substitute our values for the variables, and then we're going to simplify. So it sounds fairly easy. Let's go ahead and try it in the next slide. Okay, so this is the exact same problem. We just gave ourselves a little bit more space so that we can be a bit more clear about what we're going to do. So for the first step, we're going to write the formula for distance. And if you read up here, it tells us that r is the rate, d is distance, and t, I told you, was time. So we are going to write d. We can just write all of the words out so that it can be very clear. So distance is going to equal to the product of rate times time. Okay? Or if we want to use the variables, we said distance is d, rate is r, and time is t. Okay, good. Now we're going to substitute our values to find distance. So if we look at the problem again, rate said that the average speed of the car is 60 miles per hour. So I'm going to write here off to the side, rate is equal to 60 miles per hour. And then time is going to be 3 hours. Okay, and we want to know what is d. So that's why we use this equation. Now we're going to substitute to find d. So d is going to equal r, as we said, was 60, so 60 miles per hour, times time, which is 3 hours. So we write 3 hours. And we just multiply. So our hours cancel, our units cancel. So now we have d is equal to 60 miles times 3, and that's going to give us 180 miles. That is the distance traveled by a car going an average speed of 60 miles per hour for 3 hours. Really simple, right? If you have any questions related to this, how did we get this formula? Why are we using R and T? Why are we canceling hours? Please go ahead and let me know in the comment section, and I'll be happy to answer that for you. So let's go ahead and continue. So now this is a problem that is exactly like the one we just did. The only difference is that there's different numbers, but it is the exact same thing. And I would like for you to try this on your own. The answer is going to be in the description box so that you can go ahead and check your answer. And so that you can really get a lot of practice with this, okay? So that is it for today. Thank you so much for your attention and your time. Next time we will be discussing perimeter and area with respect to variables and evaluating variable expressions. So I really hope that you can join me for that. Otherwise, thank you so much for being here, and I hope that you enjoy the rest of your day.